In this lesson, we are going to be covering scale drawings. To understand scale drawings, we need to understand the scale factor. Scaling is the process of increasing or decreasing the size of an image. So we are going to be making an object larger or smaller. The scale factor is the one that determines whether we are going to be making our image larger or smaller. Therefore, a scale factor is a number used as a multiplier in scaling, the ratio between the size of an object and a representation of it. So when you're scaling, you're going to be actually changing the length of every single side, okay? So make sure that you're changing the length of every single side of the image. The formula for scaling an image is going to be L prime, that's going to be your new image, is going to be equal to your R, which is your ratio, times the original length. So we're going to put L. L prime equals your new length and L equals your original length. Now, once again, the new length is going to be called L prime. The single quote mark is what gives it the word prime. Now let's see the application. Scale drawing means that we are going to be making an image larger or smaller based on the scale factor. The instructions are to find the base and height of figure B. The scale factor is 3. Now what we are going to be doing is we are going to use our formula, so we know that the length of the new image, L prime, is going to be equal to the scale factor, R, and also your original length. For this example, we have a square. Therefore, we only have to do it once. Now, the length of B, our new shape, is going to be length prime equal to our scale factor, which is 3, times the side of our square, the length, which is 2 inches. Now the only thing you need to do is multiply 3 times 2. L prime is going to be equal to 6 inches. Remember, we only have a constant and a constant with units. So your units are going to be single, not square. So the length of our new image is going to be 6 inches base and 6 inches height. Now to get full credit, I want you to go to the subtitle of this part, which is example 1, and I want you to only circle with your highlighter the number 1. Once again, circle the number 1. For example 2, we are going to find the base and height of figure A prime. The scale factor is 2. So we are going to find that base and height of A prime, which is a rectangle. In the previous example, since it was a square, we only had one side. In this case, we actually have 2 sides. So make sure that you do this process twice. We are going to start by finding the length of the base. So we're going to say that L prime is equal to our scale factor times our original length. Remember, our scale factor is 2, so we're going to do L prime is equal to 2 times 4 feet. That is our base. Now 2 times 4, that is 8 feet, and that is going to be our new length for A prime. So that is 8 feet. Now our second step, we're going to do it one more time, but we're going to be dealing with the height. So L prime is going to be equal to 2 times 2 feet. The 2 feet came from right here. 2 times 2, 4 feet. And that is our new length. Okay, so the scale factor was 2. Example 3. This problem is a little bit different. It says figure A prime is a scale image of A. Find the scale factor applied to A to produce A prime. So we are looking for what number made A into A prime. Okay, so what we're going to be doing is we're going to be using our formula. So we are going to write L prime equals R, which is our scale factor, times our original length. We use R to represent our scale factor because R is also for rate. We are looking for the rate at which A increased to A prime. So we are going to use one of the length. We are going to use the base. So we are going to use 8 inches, which represents our length prime, and that is going to be equal to our rate times the base of figure A, which is 2 inches. Make sure that if you are using the base of one, then you're going to be using the base of the other one. You cannot mix and match. You cannot use the height and the base. You need to use one or the other. Now, the only thing we need to do is solve for a variable. So we need to isolate our variable. Let's leave our rate, our scale factor by itself. And to do that, we are going to be dividing both sides by 2 inches. Now, on the right side, the 2 inches cancel. On the left side, you have 4 inches divided by 2 inches. Now, our units cancel, and now you only have 8 divided by 2, which is 4. Now you have 4 equals R, so our scale factor is 4. This means that we made our image 4 times longer in height and also base length. For example 4, we're going to find the length of the sides of figure B. The scale factor is 2.5. So now we are going to make this image larger because we are multiplying by 2.5. So let's use our formula. So we are going to write L prime equals RL. Remember, L prime is your new length, L is your original length. So we are going to do this 3 times for every single side. So let's start from the left side of this triangle. We are going to start with length prime equals our rate, which is 2.5 times 3 inches. Now, the only thing you need to do is multiply 2.5 times 3 inches. 3 times 5 gives you 15. And 3 times 2 gives you 6. Plus 1 is 7. So we have 7.5 inches. Now, that is your new length for the right side of the triangle. So let's write it down. 7.5 inches. Now let's do the base, which is 4 inches. So now length prime equals our rate 2.5 times 4 inches. 4 times 5 gives you 20. 4 times 2, 8 and 2, then you have 10 inches. That is your new length for your base. So we are going to write 10 inches. And lastly, we are going to be looking for the height of the hypotenuse. That is going to be the largest side of a triangle, the hypotenuse. So we are going to write length prime equals our rate 2.5 times 5 inches. Now let's multiply that. You get 25, you carry the 2, 5 and 2 gives you 10, and 2, 12. So now you have 12.5 inches. So that is going to be your new length, 12.5 inches. That is how you use the scale factor to get a new image using every single side.